Great.
Good evening, afternoon, and morning. For me, it's morning. My name is Romain. I'm a developer with Liquidsoap. I've been working with Sam and David for all these years. Originally, we met when we were doing a doctoral degree, and I was just out of my engineering school, and we had a web radio that was working, but really we were in lack of a great tool for it. And so when I met them, it was an immediate match, and I can't believe we've been all the way to here. I'm very excited to meet everybody here. We all have had very remote years, and by nature of what we do, it's usually also a remote community. And it's difficult to sometimes understand the human side. I already had some chat on Meet with some people, and so it's a unique opportunity, and I'm really excited for that. So thank you very much for being here. So today, my talk, I'm going to skip a lot of things. So if you want to see a lot of the historical things and the background, David is going to talk about it later. But the purpose of my talk here is to showcase some of the recent work we've done, which we will end up with a release we call Liquidsoap 2, and I'll explain why this thinking. So I hope that before I start that, I hope all of y'all are a little bit familiar with the software. You know, it's a streaming language, so we have operators and functions and sources and connectors and outputs that you can use to write a little script, and that little script creates an online radio. It creates a web stream, a video stream, as we will see, and then you run it, and then hopefully everything works and works forever. So that's the basis. But what I want to show today is a little bit of the latest addition that we've done to the language. And so I'm going to start the timeline of how things have happened. I went all the way back, and I found out that the first, it was 1.5 at the time. We made it a 2.0 along the way, but the first commit on that was in July 24th of, yeah, that's a year and a half ago. Well, Sam switched the video format to UV 420, which is the most standard format in most software for that. And it was pretty important because we were just finishing 1.4, and we had a feeling that 1.5 would be very much focused on video. And so that's why we made that switch from the beginning. And before I keep going, I want to explain something that has been confusing for some people for a while. Is how we look at semantic version for versions. And I understand that for most people, the semantic version is that this is a patch version that you bump every time you do a release. This is a minor release, and usually you expect when it goes from 4 to 5 to still have compatibility, and then usually that number is used for incompatible upgrade. Unfortunately, we don't really do that. It's a little bit historical. It's a little bit for another reason. Semantic versions are really nice when your API is simple and you can really reliably just make sure it doesn't break. The problem we have is that we are a pretty complex project. You build a script, and let's say you have a metadata handler. It's going to rely on a lot of implementation details. And for that reason, it's a bit difficult for us to make sure that everything you can just update and close your eyes and it's going to work. And so usually we try to do as much as we can of bug fix release, but they're going to be on this number here. And this one here is more like a development cycle. So every development cycle, we bring up new features. We add things that might break or change, and the first release is going to be a 0. And usually after that, we're going to bump 1, 2, 3, 4 on each bug fix release, which we expect to be easily upgradable, but we always recommend to try beforehand. And this number here is more like a major paradigm change. So we're going to change from 1 to 2, and I'll explain why. So yeah, here's what it is. It's a major version, release cycle, and bug fix number. So yeah, I hope that clarifies that, because I know some people have had questions about it. So yeah, after that, we got a little bit busy because we had to finish the 1.4.0, which was the current release cycle, before we could start the 1.5. And then we got started on 1.5. So one of the first things that Sam did is native implementation of request.queue. I'm not going to go a lot on that presentation about it, but basically what we're trying to do is to move everything that was hard-coded in the OCaml code into scripting side, because it allows us to maintain a smaller kernel and to make sure that people can take over if they have specific needs or they want to change specific behavior of an operator. they can always go and re-implement their own version. And also for bug fix is great because if there is a bug, but it's only on the script side, you don't have to reinstall the whole application. You can just drop an updated version in your script. And then in February, we went to FOSDEM and we had a very nice presentation. We met a lot of the community. And I think today is kind of like an anniversary a little bit. We're happy to do it again and we should do it more often. But one thing that was amazing is that being in the same room with Sam, it just fosters so many conversations that, you know, it goes faster and we have more ideas. And so we started having a vision about a lot of things that we thought previously were completely impossible to do. And we eventually realized we could think of doing right now. So that's what I'm going to talk about in this talk. So February 10, what I started adding is the video encoding and decoding support using ffmpeg. So because of our work with Radio France, we started to incorporate more and more ffmpeg into the stack, the Liquidsoap stack, and but we always add audio. So the 1.4 release cycle has ffmpeg support just for audio. That one was the first one to allow encoding and decoding of video using ffmpeg. And the reason we're excited about ffmpeg, frankly, is that they have an expertise that we don't have, which is that they have multiple encoding formats. They support multiple muxing formats. And historically, we've been binding every single library, let's say MP3 with Lame, Opus, Theora, OG, and then doing it ourselves. But it's really tricky. And in particular, you might have binded a lot of libraries for codec, but then you need to think about the muxer, and then that's another very complicated layer. ffmpeg does all of that. And on top of that, ffmpeg has an extremely good C API. It's really, really easy to understand what the function do. It's really, really easy to understand how to use it. It's complex by nature because you're talking about a complex topic, which is how to, encode and mux formats. But when you wrap your head around it, they're really good. And there is no reason we should do redoing the wheel and not just use what ffmpeg provides. And on top of that, the ffmpeg command line is really powerful, but it's a command line. And we have something that's very much more expressive, which is a language. And so the vision we started to develop at FOSDEM was that what if Liquidsoap could be a language front built on top of ffmpeg and take advantage of everything they provide, which is what we've been working on for the past year. Yeah, so Sam started calling the shots. This one, again, I don't have too much time in the presentation, but it's a very important change. We used to carry runtime types in the language, and Sam removed all of that. It was a bit tricky because the source, when you dynamically create a source, it needs to negotiate its content, and we used to do that with types. We're doing it at runtime. I'm not going to get into details, but that was a major achievement for us, and we hope it's going to bring a lot of efficiency, because when you don't have the types to check, your code runs faster. All right, it's loading, I suppose. Oh yeah, no, yeah, okay. Then Sam started the real major change. I think June is a month for Sam. He must have been, I don't know what was going on in the world, but he must have had a lot of time on his hand. The first one is the support for modules, and that's going to be the first half of my presentation. It's a massive enhancement, and I'll go over it in a minute, frankly. It's better than to give that in detail. You'll see it in about a minute. And after that, he also added 10 days later support for errors and nullable types, which I'm also going to go over. And that was something that was really, really missing in the language. And you should bring it to a level that's also more understandable for most people who have a programming language background. And then he added support for the for and while loop, because June 20, he still had a lot of time. So I was like, okay. Right away, basically, support for modules, June 7 was where we knew that it was Liquidsoap 2 that was coming, because when you start adding that kind of change, as I say, remember the first number talks about major paradigm change, and that's a major paradigm change right there. And then errors and nullable types, for while loops, all of that, I was like, okay, we're geared for like a major release now. After that, I felt a little bit left behind, so I added this syntax that's from, I think JavaScript has it, if X is true, then Y, otherwise Z, just like it. And then splats for list and array, which I also explain in a minute. I think it's going to make programming much more fluid and easy for a lot of people. And then we started on the bigger internal change, which the first one was the extensible frame content. So what we're going to see in this presentation is how we went from having one single internal format representation for our data to being able to hold multiple content in frames and support whatever we want. So the application immediately was for ffmpeg type of content, but in the future, the kind of extension we have, for instance, if you've used OBS, on OBS, the video is layered. You have different elements and they're layered on top of each other. And then you render that at the very end, and it's very efficient because you don't copy a lot of pixels. You just, at the very end, you just wrap them together in one single operation. So if you have a text scrolling, if you have a logo, all of that is done a single time and not multiple times. That should also, in theory, be possible with this extensible frame content. A lot of things, but the idea was that, okay, now we have an abstract support where our frame content can be our internal formats or anything else. And then we use that to support ffmpeg content, which I'm going to present. And yeah, it was open. Then it was open season for all the things we've been meaning to add. So support for ffmpeg copy, which is the encoded content. I'm going to explain that in detail later. And then we added the raw, which is the decoded but stored on the ffmpeg side. I'll also give more details about that later. And eventually, oh yeah. Then in September, we did something very important for us because we were going towards another bug fix release, the third one in the 4th cycle. And one thing we did is we added GitHub Actions. We switched from our previous CI to this one. And one of the things we did for that is to start building Docker images, Debian package, and Windows binary as part of the CI workflow. So another thing that I'm not going to present, but that has been part of the 2.0 cycle is we want to harness much more on tests, CI workflow, and automatized build, because we believe that this is the only way to scale and to make sure like we do major change without breaking things. So for instance, now we have a whole battery of tests for encoding and decoding formats. So we really hope that in the future, if we break any kind of functionality, especially on the encoding, decoding, that we should be able to catch it in the test. We also know that historically it's been difficult for people to find a build, to install the application in their own dev environment or production environment. So that's why we want to provide Docker image, both in ARM64 and Intel AMD 64 architectures. We want to provide Debian package for a list of distribution we can support. I think it's Debian stable, Debian testing, and one Ubuntu. And also the Windows part. We are aware that the Windows application has some users and we want to support it as much as we can. So we try to make sure that it's not a second-class citizen and we build it every time there is a major release. So that was 1.4, took us some time away from the 2.0 cycle. Then we went back to it. We added support for SRT listener and callers for input and output. I'll get back to that in the presentation at the end, but SRT essentially is the one protocol that's becoming more and more standard for communicating data. It's a UDP based, but it has acknowledgement and real-time control. And it can be used in OBS, it can be used in a lot of places. Radio France uses it, that's how we got into it. And I'll explain why we did this in listener caller later in the presentation. And then we added video support, in particular the MP4 support also to HLS output, which was missing. So now you can receive an SRT stream, you can output it to HLS, and you don't even have to re-encode, which is something that little foreshadowing for y'all, something I'll demonstrate in a minute. And eventually, very recently, we finally added the last bits of the feature we wanted, which is the inline conversion for raw and encoded frame. It means that we have sources that can have, let's say, internal not encoded content. Then we have an operator now that's ffmpeg.encode.audio video, for instance, and it creates a new source, and that source is going to have encoded content on the fly. And the way to use it is because we want to support a feature which is you encode once and you output to several targets without having to re-encode. And so those inline conversions are the way to do it. You can also decode, you can convert to raw frames, which can be used in the ffmpeg filters. So that should bring the level of flexibility of all the different formats to a very convenient spot. So let's start with the language changes first, and let's start with the module and records. So previously, we would say you had an operator called output.icecast, and it was written as if it was a module called output and an operator named icecast. But the truth is that it was only a cosmetic thing, and internally, that thing was just a single string output.iscast. There was no reason for that. It had no meaning, no bearing for anything. What Sam did is transform that into an actual real module, which means that this output here is a little package, module, record, object, whatever, that contains all the sub methods as attributes on it. So now output will show output.dummy, output.url, etc., etc. And so it's more tightly packaged contained, it's more logically organized. But it's not just that. It also means that values can be attached methods. And that's the part that really was mind-blowing when Sam did it, frankly, because we didn't just organize things into little records. He added the capacity to attach a record to a string. So here's an example. It's the HTTP GET operator. And before we had records, the return type would be a pretty annoying, complex tuple. One would be the HTML content, the page content, and one would be the headers, the status message, status code, protocol. And you would have to really know exactly which member of that tuple was the variables you wanted. So now it's returning something that's extremely structured. It's a string. So the string is the actual content of the page. And that string is attached 4 methods. One of them is the headers. One of them is status message. So let's say OK, not found, and the other one status code 200, 302, and eventually the protocol version HTTP 1.0, 1.1. And that allows a very, very clean representation. So here's how it looks. It's a bit weird, but that's your HTML content, and then all the methods here with the headers, status message, status code, protocol version. So here's an example of using it. You say x equal https.get liquidsoap.info, and then you can call the methods, status code, status message, you get a 200, you get an OK, or you can reuse x as a string, and that's your content. And I mean, I think we can all agree that this is extremely more expressive and readable than having to parse this as a tuple, and you have to know that the first one is content, then status code, etc. Pretty impressive. But it's not just that. The other thing that's changed with it is that string can have methods, but also source can have methods. And so we've always historically had to have operators like source.skip. You pass a source, skip the track. Source.seek, source.remaining. We had operators for all of these operations, but inside in the internal of the language, source is an object with methods. So that was already like that in our internal representation. And so as soon as we were able to surface methods, we started attaching them to sources instead of having operators. And so that means that now you have a source that's a single, let's say it's passed to a file. You have a method attached to it, and you can call s.skip on the source itself instead of doing source.skip of source. It's more expressive and it's easily readable. But where it becomes also very powerful is for secondary operations. So remember we had this insert metadata operators that we've been having for a while. So now insert metadata in the 1.4 previous version would return a tuple. One of them would be the source, and the other one would be a callback function, and you would have to call the function to insert metadata on the source that was returned by the tuple. It's pretty complex semantics. Now it's much simpler because that source S here, the result of the operator insert metadata, is the same as the original source, except that we've added a new method to it. And that method is called insert metadata logic. So now we've added the capacity here to insert metadata, and you can call in your script right where you want on the source that you want. Boom, insert metadata. It's attached to it. It's much more expressive. It's much more readable. You know exactly what it's doing. You don't have to do a tuple parsing here, and it makes a lot of sense, at least to me. So we also hope that this brings a lot of clarity and brings the language to a much better usability level. The last thing that was very important for us is that there's a lot of interaction before that we could not do in the code. Because some sources, so if you look at the previous slide, this source here has an insert metadata method, but so that's the same for other sources. If you have a harbor source, for instance, it can have a stop function, but not all the source have a stop function. And so before that, we were not able to represent in the scripting language the fact that a source that was created with harbor had a stop function. We had operators like source.skip, but it was working on all sources. And there was no way really to export, the granularity of like, oh, that specific source has a specific function. And so in order to do that, we had historically used the telnet server. The source would export a telnet command, and then you would go on the telnet server and do source.stop right there. And then if you wanted to do it in your script, you had to call server.command.execute source.stop. It was pretty terrible. It was just not very usable. So the thing that's great now is that if you create a source with a harbor input, for instance, and it has a stop command, you will have that stop command exported in the script language. And that means that we don't need to have all these telnet functions anymore. So they have not been removed because one thing we try to do is every time we remove a functionality, we try to bring it back into the deprecation library. So again, part of the move of moving a lot of things to script. So for instance, remember we had source.skip as an operator. It lives, it still exists here, and you still should be able to use it in your script, but it's going to print a little deprecation message once you switch to version 2. And so what I'm getting at is that it's going to be the same for the telnet commands. We still export them, but they are scripted and they're not required. And so now with the modules and records, you should be able to call source.stop directly in your script and don't have to rely on using telnet server commands. So that's a huge cleanup element for the script for sure. So then Sam was not done. He added nullable types, which is something that was really missing for us. And I'll explain particularly why with function arguments. But the idea, if you're familiar with JavaScript, is that in JavaScript, there is a null type. Basically, your thing can be a string, or it could be null. And if it's null, well, it holds nothing. And if you do dynamically typed language, it's very annoying too, because actually sometimes the thing is null and crashes your program and you don't know. So our null type is slightly different because we know when a thing may be null. So in functional programming, it would be called an optional type. But here's how it works. You create a variable that's called null. So this one has nothing, it's X. And then you can do this little question mark operator. And the way it works is say Y is going to be equal to the content of X if it's not null, or the string that you give after that, or whatever you give after that if X is null. So here, because our X was null, Y is given the full value. But you can also instantiate null values that have actual content. And then if you do the same operator, your string Y is going to be blah. So why is it important for us is because before that, we had no way of having a truly optional argument in a function. So this is an optional argument because it's given a default value. But if that argument is supposed to be a string, we usually before would have to pass an empty string and have a convention that empty string means nothing. Oh, I haven't set an argument, but that's not always the case. Sometimes you really want an empty string. So now we're able to do that because we can say it's an optional argument and the default value is null. And then in the function, I'm going to say, oh, if the optional argument was passed, then I'm taking it. Otherwise, I'm defining the default value. And so now we have the type for the function is optional argument, optional string. And it really means that you can pass it with 0 for opt, and the function knows that you actually mean to pass no argument at all. And so here's an example with that function. If you call it with foo only, it's going to print no arg for y, and then it's going to print foo. If you pass it with the optional argument with gni, then it's going to print gni and foo. Why is it important for us? Is because it's going to clean up our API a lot. It means the operators are going to make more sense. They're going to be easier to understand. There's no special case. Sometimes we would use -1 and say, oh, if you do -1, it means the recurrent task is not going to start again. That was awkward. So now you can say we have a time, and if you pass a time with this variable in seconds, then we're going to reiterate your operation. But if you don't, we say that we know that you don't mean it. You don't have to pass -1 or special value. We already know what you mean with it. So we hope it's going to also enhance the language a lot. And finally, the last part is errors. It's also something that was really missing. Essentially, originally, the language was thought as a language that does not error because we wanted everything to work all the time at all time. but it's not the true. I mean, even if you have arithmetic operation, you divide by 0, you have an error. And so having a language without errors is kind of like a wishful thinking, and it's impossible. And so we wanted to really support error inside the script. And so that's another of Sam addition. He added this try catch error syntax. We have 2 versions. This one catches any kind of error. We have another version that specifies if your error is within a certain list. So, you know, it's if you have a specific error you want to catch, like not found, you want to catch not found because you expect that to come, and if it comes out, you know what to do, then you can catch it. But any other errors would be raised. And then in order to use that, we need to be able to register errors. So that's your API, error.register of foo. It's an error. So errors have 2 things. They have a kind, and they always have a kind, and they can have an optional message. And already you see that we can use our new null API, because we really mean none when we mean none, and we mean empty string when it means empty string. So error.message of error is the string null, means that there's no message set, and the kind of this error is foo. So you can define your own errors, and you can raise your own errors. It means that it gives you a whole layer of implementation logic for your script that simplifies a lot what you want to do. Let's say you're going through a list and you find a value and you want to exit your loop. You can raise an error, you can catch the error. Like most programming language, it should give a lot of flexibility for implementation. So yeah, typically here you catch an error and you look at the message. It might be defined. If it's not defined, you give it a default value, and you can do something with the message, maybe print it, etc., etc. And the last bit for the language is the splats. So it's a way to decompose and recompose elements. So here's an example for lists. You have a list of 4 elements. You want to assign the first element to X, then ignore the second element, assign the third element to Z, and then keep the tail in that variable T. Now you can do that. It's the syntax here. It's pretty self-explanatory. And it's going to help a lot, because before that you had to do like list.nth, it was not clear, or list.concat. So that's the other one here, by the way. I'm skipping. You also can recompose this. So we're creating a list X with 1. Then we're going to spread this list here. So it's going to be 1, 2, 3, 4. Then we put the 5 element. Then we spread again 6 and 7. It gives us the list 1, 2, 3, 4, 5, 6, 7. Again, before that, it was pretty annoying to do. We had to compose with functional operators. That just makes the script so much more readable. And we hope that it's going to make it pretty easy for you. And the last one for that is the splat for tuple. I think it's already 1.4 release cycle, but it's good to mention it. It works the same way. You have a tuple 1, 2, 3. You want to assign X to the first one, ignore the second one, and assign Z to the third one. Boom, single step. Before that, we had to do a lot of annoying things, so I don't want to talk about it. So that's all for the language. And as you all can see, it's already major enough that we have to bump to version 2, because any script written with all these things, I mean, you have to rethink and re-understand those extensions to the language. It completely changes the way you can read it. So now I'm going to go to the second part of the changes that we've added, which is internal change on ffmpeg content. And yeah, I think it's not an understatement that anything is kind of possible at this point. So let's go on with that. And the first thing I want to do is I want to try to give a little insight about how the internals of Liquidsoap work, because it's something that's a bit mysterious to a lot of people, and I think it's a good opportunity to try to explain it. So let's say it's a timeline here, infinite time, you know. There's never going to be a major catastrophe. We're always going to be here. That's your stream. We have a radio, and it streams forever. It's going to be here. It was here 200 years ago. Anyway, that radio is composed of audio. That's your audio right there. Every little dot is a sample. And it also runs forever. It's an infallible source. And then on top of that, we're going to add video. In our model, it's a regular frame per second. So each of those is an image of the video. And they are, let's say, 30 per second, 25 per second, something like that. As we'll see with ffmpeg, it's not true for all formats. Some formats have irregular frame per second. For instance, if your movie has an action scene, then you're going to have more frames. It's a very slow romantic scene, it's going to have less frames. But that's basically at a glance what a stream is. It's a succession of audio samples and video samples. Now, the first thing we're going to do, we cannot hold infinite things in memory, and we need to operate on a smaller chunk of it. So we're going to select a little chunk here that we're going to repeat over and over. So if you slide it, you have another one here. We call that a frame. Then you have another one frame here, another. And so as we operate, our purpose as a streaming software is that every frame needs to be filled, passed to the output, and sent to IceCast, sent to your local file, and we repeat, rinse, repeat. So we have an empty frame, we pass it to the operators, fill it, send it to the output, slide it, move to the next one. So typically the way we do is we're going to pick a length for that frame. Here is 0.04 seconds. Why? It's something you'll see in the logs, is because we have to find a multiple of the audio sample rate and the video sample rate. So I don't know what the settings here, but usually it's 44.1 kilohertz on the audio sample rate. I think we do 25 internally for video. And so the minimal amount, I think, would be 1764 audio samples. That would be one video sample. That's our frame. Boom. And so then we can repeat that and have a little streaming loop going on. This is important to understand because this is going to give you the minimal latency that you can expect in the software. 0.04 seconds. We cannot go under that because that's the length of our streaming loop. It's possible to go under that if you remove video. In theory, I'm not sure that we have the capacity right now to entirely disable that computation. I think we always expect some video samples even if you don't use it, but it's something we could do in the future if it's needed to like have a low latency type of Liquidsoap. Also something to keep in mind, by the way, is that if you change the video rate sample, the audio rate sample, this calculation might be different. Sometimes you might need two video sample because for some reason there is not a single minimal number that works this way. So it's also something to keep in mind. All right, now I want to explain visually how it works when we stream a little radio. So we're going to build a typical radio together. First, we're going to have a single. It's a path to a file. That file is static, and it's going to be resolved at runtime when we start the software. And if we're able to decode, we're going to assume that single file source is what we call infallible. It's always available to stream data. Usually we call that the security one. It's because we want to make sure that we can stream at all times. So by giving that as a fallback, we know that we're always going to be able to have some data for the radio. Then on top of that, we're going to put a playlist. It's going to be here just a directory with files. We support other formats, but that's going to be for today. And we can drop songs in the playlist and they are picked. But that source can fail because if the directory is empty, then you don't have anything to stream. You can have files that are not supported, a lot of things. So we call that a fallible playlist. Fallible. And then we want a request of queues. That could be like on demand saying the original Liquidsoap use, for instance, David's going to talk about it, was to like be able to send requests through a RSC channel. So, you know, think about it as like an override mechanism. If you want to play a certain file, it would be played on top of the playlist. And on top of that, you have a harbor input. So remember, the harbor input is the operator that allows you to receive a live stream into your radio, which I'll demonstrate later in the presentation. And so that's for DJs. You want to be able to support a DJ connection. So we have a little radio here. A DJ can take over and start a live show. If not, you can send on demand, let's say, or specific files you want to play. If not, you can play a regularly scheduled playlist. And if none of that work, we have a little security file here that maybe would say, oh, sorry, we're not available. Please come back later, or notify the admin, something like that. We combine all that using a fallback operator. So here, for simplicity, I've made it track sensitive for everyone. So if you're not familiar, we want to make sure when you do a radio that we don't switch from one source to the next in the middle of a track. So let's say between the playlist and the queue, for instance, if you push a new track into the queue, well, you want that track to start playing after you're done with the latest track on the playlist. So in which case you would use a track sensitive, which is the default. It knows that this one is ready, but it will switch to it only when there is a new track marker, so you don't break a track. When you do false, it's because here when the DJ starts connecting, you want this live stream to start right away for a lot of reasons. One of them is buffering. And so track insensitive or track sensitive false means that the source can switch in the middle of the track. If the DJ starts connecting, You can put a fade with a transition, but this is going to start right away. And then we want to output that to a file to save to save our show, and to Icecast to actually have people listening to our live show. And that's right there already a pretty expressive example of live radio. Now, how does the streaming work? Well, what we do is we start with the outputs and we make our way all the way down to the leaves, to the sources. So let's say we're going to start with output file and we say, hey, I have an empty frame here. Could you please put data into it, fill it? And so first we pass it to the fallback, which is the first operator in the chain. And the fallback is going to start looking at all the sources it's got. First, nothing is connected to the harbor, so can't use it. But it turns out that the request queue has a song that's ready to be played, or is playing, whatever. Request queue is ready. Boom, it's going to pass the frame to the request queue and say, hey, can you fill it? Request queue is like, sure. Boom, I'm putting some data in it. It has some video and some audio, but it's incomplete. See, we haven't completely filled up the frame, which is what we call an end of track. So in this scenario, we went and asked the request queue to fill a frame, but the request queue was that at the end of this current track, so it could only partially fill it. In this case, the frame goes back to fallback, and fallback is like, damn, I did not fill it entirely. Do I have another source available? Playlist is not available. Too bad. Doesn't have a file, whatever. But single, remember, was always available. So, I can pass it to single and like, hey, can you please complete this frame that I'm trying to fill? Yep, sure, always available. Now I have a full frame in full data. It goes back to fallback, goes back to output.file. Boom, can be stored in a file. And that's how, in a glimpse, the whole streaming loop will work. Now, next we have the output Icecast. So we do the same. We're like, hey, I'm output Icecast. I have in my own frame. Can you fill it? Pass it back to fallback. And what we do here is that we don't want and we cannot repeat. If you have a live source, we cannot ask a live source to fill its frame twice. It's not going to work. It's going to end up consuming data twice. So what we do is we cache. So because we've already been through the fallback, there's already been filling another frame, we have the cache of the content. Boom, we can copy it right away to output.icecast. Output.icecast is happy. We have completed all our output cycle generation. That's our streaming loop. We filled up the frame. And so that whole operation is going to take t seconds. And now there are two cases. The first case is we did that. Remember, a frame is 0.04 seconds. So if we were able to fill up all our outputs frame, send everything, because after that, you need to send it on the network, you store it to a file. If every operation can be done in less than 0.04 seconds, great. It means that we can run real time. And we go to sleep for whatever time is remaining after t, the difference between t and that. And then we start again with a new frame at the next 0.04 incrementation. If it took too much time, then that's where you start seeing the catch-up message. It means that your streaming system is trying to do work that takes more time than the data it produces, and we're going to start being late. And so if someone is listening to the stream, the buffer is going to go down and down and down because it's starving of data. We're not producing data fast enough for them to consume in real time. That happens a lot with video. Typically, if you are encoding video, but your encoding hardware is too slow, you're going to start seeing catch up. That happens if you have too many audio outputs. Another situation we've seen in the past is if you have a cron job that starts running and consumes all the CPU cycles, boom, this operation takes too long. All right, so that was it. And I'm going to skip next to how we did it with ffmpeg. So we start with the same thing. And instead of having samples, ffmpeg has a notion of packet and frame that I'm going to detail. And basically, it's a little nugget of content. And it's being passed as like single entity. So for audio, this little nugget is a slice of audio samples, and it's repeating along the timeline. There are more and more and more. And the way we know how they work is that ffmpeg gives us a presentation time. It's called PTS. And that tells us at what time in the stream is that little nugget of content supposed to be displayed or played or stored in the file, whatever. And it goes the same with video. See, I try to make it not regular because the PTS can be at any time. There's no guarantee of a fixed frame rate with video. And so instead of thinking of like, oh, I want a frame that's just a 0.04, a little chunk of audio, a little chunk of video, all we had to do basically is change how we approach it. So we have the same frame, it's still 0.04 seconds, but now what it means to have a frame with ffmpeg content is that, so that frame, yeah, starts from a certain time and ends on another time, 0.04 seconds later. And all that frame is going to do now is it's going to hold every single nuggets of data from ffmpeg whose presentation time is within our frame. It means that my frame tells me this is all the ffmpeg content that should be played during the duration of that frame. It's pretty simple logic and pretty high level. That's one of the beautiful things with ffmpeg API. The only thing that should be taken into account, and that's why I went in detail with this technical presentation, is that what happens is that this packet here, this audio packet, has a presentation time that's within our frame, but the content it holds might be extended beyond the frame. And that's the limitation of the ffmpeg streaming implementation for us. It means that we're not guaranteed that all the content is contained within the frame. And that is potentially a problem, because if you generate too much audio in the content of the current frame, and then the next frame switch to a different source, you're going to start seeing time drift because you have too much audio. And so you're going to have desynchronization, or potentially your user is going to start receiving too much data and their buffer is going to grow. So that means that we really recommend, and I don't know how we want to enforce that in the scripting language in the future, but we really recommend ffmpeg encoded content to be done in two ways. Either a simple relay where you don't switch between sources. For instance, you receive a stream and you send it to 3 different IceCast servers, streaming.io style. In this case, you don't have to worry about that because you have a single stream. Or you do a whole source internally and you encode once and send to different outputs, but at the very end. In theory, right now, our switch operators, fallback, everything should work with ffmpeg content. But if you switch sources and the last frame had extraneous audio or video data, then you're going to start seeing synchronization issues. So it's not really recommended, but it's possible. And so, yeah, after that, the mechanism is just the same, except that that source here is able to fill up the frame with ffmpeg content and not internal content. So let's recap what we've seen. We have a support where inside of our frame, we hold little packet of ffmpeg data. There are two kinds of those data. One of them is a chunk of encoded data. It's called a packet internally in ffmpeg. It's a little bit of encoded audio or encoded video. It's completely opaque. It's abstracted by ffmpeg, which is beautiful. It means we don't have to know what it holds. We can, but we don't have to. And we can pass it around and send it eventually to an output. The other one is, in Liquidsoap, we call that ffmpeg copy, because I think it's the most semantically sound way of saying we use that to like copy the data without having to decode it. And the other one is a chunk of decoded data. So ffmpeg has already taken your MP3 and decoded it into PCM samples, but it's stored on the ffmpeg side. It's not stored internally with Liquidsoap. The reason for that is that it would allow Liquidsoap to operate on data that's allocated and freed by ffmpeg, which I think in certain situations can be more efficient. But also, this is the format you want for ffmpeg filters, because the filters, which I don't have time in this presentation, we also support all the generic filters that ffmpeg has, and they want raw data as input. So we support it particularly for that, so you can actually use ffmpeg filters. So it's called ffmpeg raw in our internal keywords and denomination language. So now here are the features we have. We have decoders that can decode copy, so they send encoded data in the frame. They can decode raw, so they send decoded data but stored as ffmpeg data. We have encoders that can receive encoded data and send them, mux them, and send them without re-encoding. Okay, you know the drill. Then you can receive raw frames. We have inline conversion, which I'm going to show, and ffmpeg filters, which I'm not going to talk about because unfortunately we're running out of time. So yeah, here's an example of an encoder. That's an audio and video. This one is going to be encoding internal format to an MKV container with audio and video like that. Then you can encode raw. So in this case, we're going to expect raw data, or you can get a copy of the audio. So here's an example of using that. You have an arbor input, it receives data, and then you plug it into an IceCast and you say, I want a copy of the audio. The way this is going to work is that this is going to tell the input here to not decode, but to use the ffmpeg copy decoder, which is going to start outputting packets and pass them, encoded without touching them. And then where it becomes really beautiful is that you can also use it with an HLS output, MP3, with another copy encoder, and that means that now we're going to receive encoded data and send it to IceCast and HLS and not touch anything. This on your CPU is going to be close to 1%, and you can start sending to ton and ton and ton of output without having to re-encode. I'm going to skip a little bit over it because I'm running out of time, but the way it works is that in the type system, we say it's a copy of quote A. We don't know really what the content is. Then the first decoding we do, we find out the format. We pass that to the source. The source says, okay, I don't need video here, but I'm keeping the audio. And then instantiate that thing with all the details of the format. And we want to do that because then we want to make sure that every file, remember when we copy data, the data needs to be the same. If you start outputting AAC at a certain kilo rates, if you want to put another file after that, it should be the same format. So we're going to use that internally. And so next, the source is only going to accept files that have that internal format. So we know we're consistent here. So that's the converter. You can use that to take a source that has internal data, so audio, video here, so audio and video, and then you pass an encoder and you return a source, and this source is going to have encoded content. So how to use it? You create your source, then you say encode audio with MP3 format, this case, and boom, you can output that to 2 different IceCast with a copy encoder here. What that means is that here we've achieved encode once, output multiple times. But you can, so that's something we thought was impossible less than a year ago. And now, but this where it gets really slick is that you can also do it for audio and video. So this encode audio AAC video in X264. And then what we can do here that's amazing is that we can do an MPEG TS wrapper that copies and an MP4 wrapper. You need a little bit of options because what we're about to do is HLS, and MP4 and HLS is slightly hacked, frankly. And so, yeah, we're able to do an HLS output of both MPEG TS and MP4, but encoding the data only once. And that is beautiful. And I'm not even sure you can do that with the ffmpeg command line, frankly. So yeah, when I was saying anything is possible, this at least for me, it's pretty amazing. All right, and I'm going to my final demonstration, which I really hope is going to work. I'm working on the computer that I installed specially for this presentation. So I had to set everything this morning. But let's try. We're going to do something that I think, to my knowledge, has rarely been done, if not ever. We're going to take a browser, and now, we had this webcaster thing that back in the days was able to do audio. But now, it was 6 years ago now, the JavaScript API finally has a media recorder. Because before that, we had a JavaScript compiled version of the main library, or the Shine library, I forgot. That was basically encoding data using the JavaScript stack, which worked because there's a thing called IRM.js, which is an optimized pseudo binary code for JavaScript. That, man, that was something else, and it was barely real time. But now we have a media encoder. It's in the C stack or the machine stack, machine code. It can encode audio and video, and it works and gives us the encoded data. It's beautiful. So last week we took a minute to brush off our implementation and add support for video, and it's beautiful. We're gonna see it working, I hope. The way it works is that the browser sends to Liquidsoap data over a WebSocket. That data is the result of the media recorder encoding. Liquidsoap receives it through input harbor. So the input harbor is able to receive an HTTP connection and upgrade it to a WebSocket connection and start receiving data from the browser, packet by packet. And then on the other end, we have OBS. And OBS is gonna ask Liquidsoap for some content using the SRT protocol that I was telling you all about. And so Liquidsoap is gonna be able to pass whatever the browser has encoded to OBS without re-encoding. So we're basically a proxy here that should allow people to do live video stream on whatever platform you want, OBS, but we can output HLS, we can do a lot of things, even output RTMP if you want to send it somewhere else. All right, so this is the part where I need to switch to screen presentation. Let me try that. All right, yep. Yep. Should work. Ah, access to screen was not granted. Damn. I'll try it again. Application window, maybe. No, all right, it doesn't work. Sorry, but I have screenshots. That's why we do that. So here's the application, how it looks like. Y'all can try it. It's a webcaster client. It's on GitHub. We have a little camera here that you can enable. You can put some files in playlists, 2 playlists. You have a mixer between the 2. You have the microphone. What I would have loved to do in the demonstration is if you click on Q, it's going to start playing the audio on your speaker, so you can know what's coming from that source. You can click on Q and see what's coming here. And once you've enabled the camera here, it's going to give you a couple of output formats that you can pick. Those are the formats that are supported. And so then you can start streaming. What's going to happen is that on the other side, we have a little Liquidsoap script, which is just that. It's 3 lines. It's an input harbor, receives on mount, default password, whatever. And then, yeah, it repacks as copying audio, copying video in a WebM format, which is the format that's already received. That's the one that works for everybody. And then output SRT in the listener mode. And listener mode means that it's going to open a socket and wait for whoever wants the data to come ask for it. And so that's going to be our SRT server. So on the other end, the last one is going to be OBS. Here, that's me. You put this little SRT URL and you say that's my output, and boom, it's going to start reading what's coming from your webcam. And the thing that's beautiful is that it's very powerful because we actually do the video with this playlist here. So it's going to start seeing what's here mixed with the audio of the result of all that. And I don't have it. I would have done it if I shared the screen, but it's also the synchronization pretty amazing. And eventually, boom, that's it. You got a video in your OBS. You can do whatever you want. It's coming from a browser. It means that you could put it in a tile here, have different people, and then stream that somewhere else. That's it. Sorry, it didn't work. I can try one more time. Maybe see if there's an access that's not granted. I don't know. Why is it? And I don't want to ruin everybody's time. Manage, maybe. View permission. I might be able to do it. Wait a second. Notification, images, pop-up and redirect ads found. Well, I don't think so. Clipboard, insecure content. All right. I don't know where it's at. It's not working.
Maybe we can take questions now and
well, I have one last slide.
Okay.
I think I'm still within the time, right?
Yeah, of course.
Okay, cool.
I think it's better to try things within the break.
Yeah. Well, it's good because if other presenter needs to share the screen, it's good to know it's managed. So what's next? This is a lot of change, y'all, and we've been rushing through it. Not rushing, but we've been doing the code first. And I think the idea after that is to start to clean up and fix bugs. Of course, those major changes, they are very hard to guarantee that everything's going to be working. And we're going to have to do some cleanup. That's where we need help from the community. We love to have different use case, people who have ideas, try it, be a little bit daring and report it to us. We'll try to be as fast as we can in fixing things, diligent. We need to reorganize. Oh yeah, so another thing I'd like to do is, now that we have modules, we have a thing where we can open modules, and I would like to rethink the API a little bit. So originally Liquidsoap was only audio, and then we added video, but it's kind of like a ghost thing. Like most operators, they need audio and they're going to do something if there's video, but they don't really need video. So it kind of is invisible in a way. It's like second-class content. What I'm thinking, I'm envisioning is like, you would have an API, let's say that if you don't do anything is, let's say audio only, maybe it's almost a typical use case. And then the fade operator is going to refuse to have video, and everything refuses to have video. Then you want to start using video, you say open audio_video, and then boom, all the API is the same, except that you're going to have expect both content, audio and video. Or you could have a module that say video only or video, and then you open video only, and then all the content is video only. I think it would make things much more clear, and it would allow people to understand how things work and are expected. We need a complete overhaul of the documentation. As you can see, it's a lot of things have changed. A lot of things that we considered impossible are possible. We need to explain that synchronization issue with ffmpeg. Sam and I had a book in the works last year. We kind of put the hold on it when we realized we were about to do all these changes, because there was no point in finishing a book that would be obsolete right away. So we want to resume the work on that and use that as a new documentation. And we could use a lot of help on that for sure. A review, suggestion, even maybe writing help. I want to have an RTMP input is really missing, because this is one of the standard things for a lot of streaming, video streaming situation. The problem is that RTMP is it's an old Flash protocol with a ton of things that are not useful. It's basically used only to receive video, but if you want a proper implementation, you have a lot of HKs. There's no OKML module for it. There's not really a good C API. There's an excellent Node implementation that I might just want to replicate, but it's a lot of work, so I'm not sure if we'll have time. ffmpeg has one, but it's really minimal, so I really want it, but I'm not sure if we have time. If anybody wants to contribute or help, I'm happy to mentor. We might even be able to compensate. That would be a great feature. I'm not sure if it's going to be in the cycle. And we want to implement awesome features that the user are giving us. So SRT, high quality video server, which is kind of like what triggered that little experimentation I showed, and whatever else you guys have in mind. I think at this point is pretty open. All right, I'm done. Thank you for the patience. Yes, we can take questions if people want to ask anything.
Thank you very much. So is there any question for Romain? You can open your microphone or ask on the chat as you wish.
Romain?
Yeah.
Hi. I was wondering, do you have any, so Liquidsoap is growing, it's getting better, it's doing a lot of things. It still looks like it's a big game to do whatever new idea you have with Liquidsoap, and well, you try to demonstrate it with webcast, and it's a pity it didn't work, but well, I'm sure it does in normal circumstances. But what about the normal applications? What is your estimation of how people actually use Liquidsoap in the field? Is it still just net radios, or is the video application becoming even more important than audio?
I think it is. I mean, that's the beautiful thing for today. And I like your question because it's great. We're about to see a lot of presentation about what people do with it. Obviously, a lot of people still use it for audio, but the video is coming up. Some people have like live YouTube channels that add computer-generated graphics on top of their radio. But to be clear, we still do intend to support audio only, and this is not a change in the support that we have. Is an extension of the support, and particularly I feel like the capacity to keep audio encoded and relay it to encode once and send it to different destination is also a feature that's going to be beneficial to a lot of our audio only users.
Hello, Romain. And Thursday, thank you for all this work. It's really wonderful. And it's great news to see all this. You mentioned that the telnet server might change, but I'm not sure I understood how. I'm asking because I know that many systems are relying on this telnet server. So what happens?
No, it's not going to change. It's not going to change. What we're doing is that everything that the telnet server provided is now provided as a method on the source. So it means that you can do it directly in the script without having to go through a telnet function. But we've added wrappers for all the telnet functionalities so that when the source is created, the telnet command is registered as it was before. And so we're really hoping to maintain exact feature parity. And as part of the cleanup cycle after that, if people come up and it's like, hey, I'm trying to switch my script to Liquidsoap 2, that telnet function is not available anymore, we will make a point to fix that and provide it as it was previously.
Wonderful. Thank you again.
Absolutely.
Any other question?
Hi, can you hear me?
Yeah, Mister? Yeah.
Hi. First of all, yeah, big thank you to the Liquidsoap team for all your continued work. We've been happy to be downstream of you for quite some time now. My question is the Liquidsoap 2.0 roadmap, do you consider that fairly fixed in place at this point, or do you consider it still very much evolving, and would you be entertaining like new feature requests for things to actually throw in there, while you're redoing everything, while you're rebuilding stuff, would you?
So that's thank you for asking. The way I look at it, like I'm done with the major fundamental change that we were looking for, especially on ffmpeg. I have most of what I wanted, and I would love to not have to change too much of the internals, because it's a lot of work and it's pretty not scary, but But as it comes to new operators, new functionalities, of course, we're still open for suggestion, and we would love to hear more from users about what they think is missing. As I say, typically RTMP input, I would love to bring it. Yeah, and when it comes to the roadmap and the timeline, I haven't mentioned it. We will try to do it soon. We're still we're still a labor of love based group. So we have to think about like I have a stable bug fix release that needs to come out, and that takes some time out. So we'll try to like move at a good pace. We're still open for new features, but also I would love to maybe have something ready by 6 months from now or something.
Excellent. Thank you.
Other questions or comments? So there is a question by John and Romain on the chat.
Yeah, no, the language is not changing much. We're basically extending. There are a couple of breaking things. I think, as I said, we are in the process of moving as much as we can into the scripting side. So Sam moved the reference to the scripting side so that we have a smaller code base to maintain in OCaml side. So that's a breaking change. It's pretty minimal. You have to add parentheses when you do a ref. But for the most part, the language as it is not going to change. I will also venture to say our language.html page is pretty much overdue for a makeover. So we will work at remaking it, but the content, essentially the language is not going to change. Hopefully the doc is going to improve though.